If you have different data, you have a different problem. And how does that relate to model view controller? Um, so I have a project I'm working on, and in the past I've definitely done like a model view controller thing, right? You have the model, which is basically your data, your view, which is the UI, like how to render that data, and the controller would be mechanisms for allowing the user to manipulate the view or manipulate the model. So actually, a lot of times when I do a model view controller, I'll do model view, and then I'll have two controllers. I'll have a what I will call like a low level pragmatic controller, right? Like so, like different functions that are meant to be called by the user, and then I'll have like a user controller, and the user controller is like the nitty gritty aspects of like, okay, maybe the user needs to click and drag, but after they click and drag, another function gets called, right? So the clicking and dragging code that would be in the user controller, and then whatever function needs to execute after they've clicked and dragged might be in the low level controller or the pragmatic controller. So I would actually do model view and then two different types of controllers, because I find that a lot of times I want to separate code that can be automated from code that is kind of highly coupled to user input. And that makes it easy to do things like, let's say you want to be able to take like your AI in your game, and then you want to like be able to like move it yourself with the keyboard. So if you have your controllers split into pragmatic controllers like jump function, move left function, move right function, and it's separate from your user controllers, then it's a little bit easier to like swap out code, and the code. All these functions were controlled by AI, but now you can just swap out some code, and now all these functions are controlled by your user inputs. So separating what could be automated by a computer and what absolutely needs to be highly coupled to user input, I feel like it's really good to separate those. Okay, so anyways, model view controller. Okay, that's all great and everything. And it's a sensible division of things, I think. However, there's a problem with it, I think, which is that, how many times have I written a piece of software in model view controller, kind of layout or design, and then I never add another model. Like, I never add another data set. I never add another view. I never add another controller. So it's like, what the fuck was the point of, like, adding these different pieces? And maybe it's just, maybe I'm biased because I have a very modular mindset. So I'm like, oh, model, view, and controller, right? So you can swap out different models, swap out different views, swap out different controllers. So maybe I have a misunderstanding there. And that goes back to the quote I said at the beginning. I forgot who I'm quoting. Was the data-oriented design talk. If your data changes, your problem changes. So if that model changes of the model view controller, if the model changes, you need a different view, you need a different controller. So I have standardized the data for a game I'm working on where everything is just going to use 512 by 512 bitmaps in memory. Like, everything's going to use it. That's going to be the standard format for everything. So if it's, it doesn't matter what kind of information it stores, the information is always going to be stored in 512 by 512 bitmaps, RGBA. Which could lead you to being able to take a block of 512 by 512 texture memory and plugging it into one model view controller to edit it and see it one way, and then plugging it into another model view controller to edit and see it another way, which I think could be a really neat thing. But then your code can get very tangled if you do this thing where one model can have many views and many controllers, right? Because you got a one-to-many relationship. And I find that managing these one-to-many relationships, or, oh, it has a one-to-many relationship with this, but then has a one-to-one relationship with that, and all those things, I think, make it way too complicated. So, I suggest another way, which is not as friendly with memory resources, but I'm only using a 512 by 512 megabyte chunk of memory, and sorry, did I say 512 by 512 megabyte? That would be a different story. 512 by 512 pixel chunk of memory. And in this current age, I don't think that is too extreme usage of memory. So rather than have this trying to set up one-to-many relationships and just getting your code all tangled, what I would suggest is you have one model, one view, and one controller, and they're all paired in a one-to-one-to-one relationship, and they're not allowed to be mixed and matched. Now, if you want to interpret your data from your data in one model as a different type of model, what you would do is you would copy that block of memory into the other block of memory that's associated with another model view controller. And, maybe you're saying, oh, that's kind of ugly, that's not quite elegant, but it's dead simple, and code gets really complicated. So I think that's the way I'm going to go with this, as I've been thinking about it. I'm also trying to design the code to be, it's very data-centric, and then it's also very editor-centric. So, I'm trying to do a data-oriented design, which I have a vague idea of what that means. You you're not trying to hide what the data looks like. You're not trying to do data hiding and encapsulation. You're trying to really expose what the data actually looks like. So maybe I do understand it, maybe I don't, but I'm giving a shot at data-oriented design where I am doing, instead of a header and an implementation file in my C code, every single sub-library is divided into a data file and a functions file, and data always comes before functions. So when I'm including libraries A, B, and C, I include A.data, B.data, and C.data, and then I include A.functions, B.functions, and C.functions. And the nice aspect of doing it this way is you got to remember that functions operate on data, right? So if you ever had a dependency loop where class A uses class B, but class B uses A, right? There's that cyclical dependency. Well, a lot of times what's really happening is class A uses classes B's data, class B uses classes A data, right? So there's not really a dependency loop. There's actually this artificial dependency loop where, because the classes are tightly coupling data with functionality, you get dependency loops that don't actually exist, right? They're artificial. So if you include A.data and B.data, and then you include A.functions and B.functions, well, A.functions might reference B.data, and B.functions might reference A.data, but there's no dependency loop anymore, right? Because you included all of the data files before you included the function files. So I think that's a pretty good design. It's a little bit different, right? Because usually you think header and implementation file, but it's like, nope, that's not how I want to look at it. I want to just be open up the file and see what all the data is. And then if I want to know more, I want to open up a file and see what all the functions are. Now, if we really need a public interface, we would make a .p file for public interface, and we would include that after everything else, right? So include all the data files, include all the function files, and then include all the public interface files. It's very important to include the public interface files last, because these public interface files are really just for documentation. They're not meant to be forward declarations. And if we include the public interface files first, where it has all of the function prototypes, some people might call them function signatures, but I guess the correct verbiage is function prototype. What is the return type of the function, how many parameters does it take, those things, but none of the implementation details. You don't want to include that stuff at the beginning of your C code, right, before you've included any of the implementations, because then it will act as a forward declaration, and we don't want that. We want a very strict ordering. And, when we use this very strict one-pass type of ordering, it does make it so that we might have to order things in ways that we think are weird, like an inverted pyramid. Like we're going from, you're going to have to put the nitty-gritty details first, and then the higher level functions have to go last, right? Because the higher level functions call the nitty-gritty detail functions, right? And if you're not using any forward declarations, then code that calls other functions has to come after those functions, right? And so you might not like it that way, because you're like, oh, you want the high-level view of things before you get into that low-level view. And I mean, you can still do that, you just gotta scroll all the way to the bottom. But the nice thing here is, if you don't use any forward declarations, you always know where to find something, right? Like, if you're reading a function and it calls another function, you absolutely know that that function is located further up somewhere, right? You can find it. Also with that idea is strict namespacing. So I put a namespace for the project, and then I use a namespace for the sub-library, which makes the code very verbose, and I don't really like verbosity, but it's very important to be able to find things. In fact, code is really just about connecting the dots, and you really need to be able to come back to a project months later and just be able to figure out how everything is connected and jump around from part to part and still understand how things go together. Also, with jumping from part to part all over the place, sometimes code creates a complicated web. So I also think that you should try to minimize how webby your code is and try to keep it as linear as possible. So I'm also experimenting with the idea where I code my project as a series of libraries, and just like in the idea of no forward declarations, where a function that calls another function must come after the function it calls, I'm doing the same thing with my libraries, where the first library cannot reference any other libraries. The second library can reference the first library. The third library can reference the first and second. The fourth library can reference the first, the second, and the third. The fifth library can, reference the first, second, third, and fourth, right? So whatever library number you are in a chain of libraries that was included to the project, you can only reference the libraries that were added previously. The effect of that is trying to create a project where I can slowly build up and layer on a new functionality in a very linear way. So that way, when somebody comes to the project who's new to the project, they can see how these libraries were layered onto each other, and they can understand immediately when certain things were added, and they can also understand the thought process. It's kind of like looking at the fossil layers and seeing the different layers and the strata and being able to derive different time periods and what was going on at that time. So by making this very linear and enforcing that linearity, we can also kind of keep that record in the source code itself without even having to look at any git commit history. Every time I've been on a project where I was not the one to start it, I'm at a huge disadvantage, because the people who started the project don't realize how much knowledge they have just from the experience of building up the project. They have a superior mental model. And if you can string together these libraries in a very linear chain, you can help to give newcomers an experience of having built up the library themselves from the very beginning. Sorry, I got some allergies. So with that, the other idea is that we want it so that with that library chain, we want it so that later we can compile up to any library, right? And anytime we do that, we still have working projects. So let's take a look at that. So let's see. Display capture. So if we go over to, that's not the right monitor. Actually, maybe that was. Yep, that is, okay. So if we look at some of my code, let's move this over a bit. If we look at my code here, you'll see that I have these library chains, and there's a strict ordering. This is telling me the current compile to here. So libchan cur says that I want to go up to paint 5D. So I'm going to include all of the libraries up to paint 5D. Now, if this were a 5, I would compile this, and this. I'd compile all of these. And no matter which number I pick, I'll always have a project that compiles and runs. But this allows me to kind of get an idea of when certain functionality was added, and gets an idea of like how do we build up this project, right? So, a native keyboard and a window. So the window probably needs access to the keyboard for some reason. And the reason for that is the native keyboard code for Win32 has like different keyboard events. So in the Windows message, it can it has a case for WM key down, right? So if we want to interpret WM key down, we're going to need some type of library that has a list of like the native keys and some type of way to like interpret those keys. So the dialog UI, well, it's right here, so that's saying that, you know, it must either need the native keys or the window. In this case, the dialog UI actually just needs the window in some cases, because it needs to know about a parent window. Now, you know, sometimes not everything's linear, right? So this is just how it... This is like a strict ordering, right? And then over here we have like a diagram where this is like a conceptual order. So if you see something like here where we have GinoWin here and then we have these three libraries right here, it should be like, it could be 1, 2, 3, 4, and then 5, or maybe it's 1, 2, 3, 4, and 5, right? By the nature of code, nothing can be completely equal, right? We can't add these to our includes at exactly the same time, right? One has to come before the other. But conceptually, they may be conceptually added at the same time, because they don't depend on each other. This GL bind needs GL wind, CL bind needs the window, and this bind needs the window, right? So setting up OpenGL requires the window, setting up OpenCL requires the window, and setting up Vulkan requires the window as well. So conceptually, these are all added at the same time. However, we're going to have to enforce some type of strict ordering, right? So here is the strict ordering, and the strict ordering gives us Um, I think, that's kind of an aspect of the data-oriented design, right? We have this conceptual design here of how things are put together, but here's like how it actually is put together, right? Here's the actual linear enforcement of how all these different libraries are going to be put together. Um, so when you think about the World Wide Web and how everything is at your fingertips, right? All the information is at your fingertips, right? I think the challenge in today's modern world is relinearizing information. Meaning, it's so easy to like categorize things and put them in a folder structure, and then you lose track of something because you put it so deeply nested you just forgot about it. Or like I've seen things with projects where it's like, well, does this go in like geom.shaders or does it go in shaders.geom, right? Like sometimes you get this problem where when you start to too deeply nest things, your source file ends up having more than one logical place where it could belong. And I know why people do it, because it makes it more manageable. It makes it easy to partition the space and search for things. So I totally get why people would do that, and it totally makes sense. So I'm not saying that's a bad organizational strategy. I'm just saying that for me, I don't have much success with it. Or I mean, I guess I've had success with it, but that aspect of having to refactor things sometimes because, oh, it doesn't quite fit in this category anymore, and thinking about the exact category it goes in, and it goes in more than one category, like all that thought about things that are really trivial and really shouldn't matter annoys the hell out of me. So with this project right here, like if we open the containing folder in Explorer, we're going to see that I have dependencies, documentation, and library, right? So we have some nested structure in this project. Dependencies, so load PNG, and then one of my own libraries. And then in the documentation, just a list of different things. These are actually the names of comment tags. So sometimes my comments get very verbose. And the last thing people are going to read are the comments, right? So when they have no other recourse but to read the comments, then they read the comments. So because of that, you might as well get rid of that visual clutter and just throw it here, right? Because this is going to be the last bastion of figuring out what the hell the code is doing, right? So what I'll do a lot of times is like, this thing says data then functions, right? So somewhere there's a comment in my code that says hashtag data then functions, right? And tells me to kind of look in this documentation. Or ycog in diagram. Like I'm pretty sure if we go down here, we have, yeah, so c doc ycog in diagram.txt. So we have this nice slender diagram, and obviously this is already a lot of comment, but we have more, and if we double click this, we already see, a big chunk of comments, about 15 lines, and we can get rid of those lines, right? And, it starts to really add up, because if you think that all of these are at least 10 lines, 10, 20, 30, 40, 50, 60, 70 lines of code we're kind of saving, roughly, right? Because maybe we're off by one, because if we're saying that's 10, well, we're replacing with the hashtag comment, so really we're only saving 9 lines, but you get the idea. We're going to save a lot of lines of code in our project, and it's not that, don't be afraid of like long functions, but also be afraid of clutter. And so this project might look kind of weird because this is the main file, and really what it does is it just chains together and manages all of the dependencies. So it does look very verbose and fluffy in that sense. But let's look at what else we have here. Or let me backtrack here. So I've kind of given a review of like what I'm working on, but the current task right now, I guess the problem I'm having is Oh, yeah, we were going over the linear structure, right? So in lib is the last thing. So all of my libraries, I'm not putting them into any subfolders. I got data and a function. Data, function. So D for data, F for functions. So for each one of these sublibraries, we just have a data file and a function file. Sometimes I have something that breaks that pattern, like here we have a public interface file, but everything just laid out right there. So I don't have to figure out, oh, what category does that belong in? I don't care what category it belongs in. What I care about is this. This is what I care about right here. That I know relatively where these different things are added. So instantly I know the exact dependency chain. And also, I know a quick summary of what it does, right? Like if I can't remember these little, they're not acronyms, but phonemes. Let's just call them phonemes. If I can't remember these phonemes, then I can look at these little summaries. Native keyboard, graphics in window, dialog UI, OpenGL easy bindings, graphics squad, basic uniforms, fragment testbed, GPU data, pixel data names, GPU, right? So right here, rather than having a complex nested folder structure where things get really deep and things get buried and you forget about things and then you end up programming the same goddamn library again because you didn't realize that there was a library that already did that because of the nested folder structure. Well, we don't have that problem because we just have everything out there linearly. Now, the problem with that is you can get overloaded. Like, if this gets up to like 100 different sublibraries, that's going to be kind of like an information overload, right? Because you're getting blasted with like everything right away. And so when you have a nested folder structure that kind of like hides all the complexity, it can be like easier on you mentally. But I don't think that being easy on you mentally, I don't know if that's actually good for you. I think it's like, it would be a lot easier on you physically to not lift any weights and not get any exercise. Yeah, sure, I guess that would leave you with a little bit less stress, but in the long run, I don't think it's going to be good for you. So I think in the long run, like, this might give you, like, this data overload, but I think it'll be better for you in the long run. Okay, so with that, you will see that there's a little bit of nested structure in here, but it's not like a requirement of the pattern. So, for instance, fragbed default shaders. Well, we know fragbed default shaders. We instantly know that it goes to fragbed, right? Because I labeled it with fragbed here. And then I'm like, well, I want to know what's in there. Like, why did I have a subfolder to break this pattern, right? Because most of it's very linear and there's no nested folders. And I didn't just want to call this fragbed because if I called it fragbed, that invites more nesting, right? Because then we can go fragbed and then have a default shaders folder and a default whatever, right? A fragbed slash this, fragbed slash that. No, I didn't want to do that. Like, let's say fragbed needs another list of files, then we just put it at the root here, and we call the folder fragbed underscore, and then what other resources we needed for that, right? Keep it as flat of a file structure as we can. And these are just default fragment shaders. So with that, that's the structure, and now the problem I'm having. So this GPU data paint 5D. So this kind of breaks part of the pattern where I decided I want to absolutely know that paint 5D is derived from the GPU data. Like, I thought that would be helpful in the future, just because now I know I have more information there. I know that paint 5D is somehow related to the GPU data. But now you have GPU data.data and GPU data.functions. And that's kind of confusing. But not too confusing, right? GPU data functions is functions that operate on GPU data. GPU data is .d is just the prototype, is just the struct for holding the GPU data. So this actually makes sense here. Now, can we... Oh yeah, because Windows sucks. So once upon a time, when you zoomed into things, the font would actually get bigger. But since like a few years ago, you can no longer change the text size in Windows, which is really annoying. I had a custom file explorer at one point. Anyways, so sorry that you can't see this. So right now we have GPU data paint 5D. The actual data and the actual functions. So this right here is just a instance of whatever this is, but it's an instance with a very specific purpose, which is to create a 5-dimensional paint program. And then here are functions that I want to use to operate on that. So my problem right now is going back to the model view controller thing. So let's so looking at this model view controller problem, can we put that on the put that up on the top? So model view controller. The problem I'm having with that is, well, this is called GPU data paint 5D, right? Do I need a editor paint 5D, right, or a controller paint 5D, and then a technically this is like, this right here would definitely be my model for paint 5D, right? It's the data for paint 5D. You could call this the controller, right? The functions could be the controller. But then where's the view, right? So I know that for rendering this, I need some GLSL code. And if I fractionate it into one more library, that makes everything easier to manage, right? Smaller pieces are easier to manage. But if you fractionate it too much, it can be very hard to, like, find things, right? Because everything's spread across, like, 100 different files when it should only be in one. So there's this thought of, like, how should I fractionate this? Should I take this GPU data paint 5D and fractionate it into a model, view, and controller and make those separate files? And part of me is like, okay, maybe. But then the other thought is, I've already named this GPU data paint 5D, right? Which is to tell me that paint 5D has some type of very strong relationship to GPU data. So strong that the namespacing in GPU data is GPU data paint 5D. So usually it is, here's the library namespace. This is the main project namespace here. And then usually it would just be namespace for the project and namespace of the sublibrary. But now I have another namespace added on. So usually there's not 3 namespaces, which kind of is a pattern breaker. I made a note here, pattern breaker. Because you're expecting everything to have 2 namespaces, and then this has 3, and then you might misinterpret this as it being in GPU data sub-library, and that it's something called paint 5D dat, right? Like, you might interpret it as library, or you might interpret this as project, sub-library, and the actual variable name, right? But in actuality, it's project, sublibrary, and then the actual variable name is here. So that's kind of a pattern breaker, because you already see the split here, but the sublibrary is actually these 2 things. And now if you go into here, right, you can obviously see that, yeah, the sublibrary, that's what it's called. And the reason for that is I wanted to maintain that paint 5D is very strictly tied to GPU data.d. So in here, in my right here we have, right, the library, or actually the project, sorry. We have the project name right here, and then we have the sublibrary. But I wanted to make sure that it was very obvious that paint 5D is connected to this GPU data. So this struct GPU data, Paint5D is actually an instance of this. Now, if we go into Paint5D and we look at the functions of, sorry, not Paint5D, if we look at the functions of the GPU data, right, we have some basic functions for how to manipulate the data on the GPU and abstract the array of bytes as a two-dimensional bitmap that uses RGBA color. So when we're thinking about model view controller, you could think of this as a low-level controller, because it's going to use the most basic useful abstraction of an array of bytes to operate on that array of bytes as a two-dimensional array of pixels. And then we'll add other abstractions on top of this basic controller, right? So here's our core data, here's our core controller, and then GPU data Paint5D is going to create an instance of that core data that has a very specialized purpose, and then within the functions for Paint5D, so Paint5D.functions, we will have very specific functions specific to Paint5D. So GPU data, Paint5D init, and so here's the initialization function that's going to set up the Paint5D data, and then maybe any callbacks or controllers or things that need to be set up. So we initialize the instance, and I use kind of like a builder pattern, but a very rudimentary builder pattern, where we take Paint5D and we fill out some of the things we need to fill out right here, and then we send it off to the init instance in the GPU data library. I wanted to say class, but really I should be calling this sublibrary. The GPU data sublibrary is going to initialize this instance. Also, I called this GPU data init instance, and that ordering is very specific. So a lot of times, all my libraries have like a init function. So if I look for GPU data init because I forgot that there's an init instance function, I'm also going to stumble upon GPU data init instance, so I won't forget about it, right? Because forgetting about what is in your code is a big problem once your code base gets pretty large. So anyway, so now that we're kind of here, the problem is, do I want to manage everything that Paint5D does with just this data file and this function file, or do I want to make another like Paint5D controller library and a Paint5D editor library? Like, do I want to do that? And I'm leaning towards no, just because it's going to for two reasons. It's going to fractionate the code into more things. And while I do like making things into manageable pieces, I'm not sure. I think it would be more detrimental. Also, I want to abide by, like, in this library chain, like, every time we add another library, I kind of want some type of different visual when the program starts up, to kind of, like, let you know that you're in a different project now. A different visual or a different mechanic or something. Now, I can't always satisfy that, but that's kind of what I would like. Every time I build up another piece, you can kind of see a different functionality. So it's almost like, if I build up to here, it's almost like a time snapshot of what the project looked back when this was first added, is kind of how I want that to work. And there's another concern, whereas if I try to fractionate the Paint5D library into another Paint5D library for the for a controller or for an editor or whatever you want to call it, well, we already have this libchan order Paint5D. So Paint5D, that word kind of has already been reserved for GPU data Paint5D. So right now it's almost as if Paint5D is synonymous with GPU data Paint5D, right? And that extra library namespace is just there to help you, as somebody who has just come to this project, be able to quickly make that association that, oh, Paint 5D is somehow highly coupled to GPU data, right? And that's kind of like what I want to force there. And so if we have libchan order Paint 5D and we're looking at this, right? So we have include Paint 5D. So let's look at where include Paint 5D is. So, if if we're compiling up to library number 10, then we want to add the Paint 5D library. That's what this is saying, right? So we have this big chain here, and data before functions. So if we're compiling up to library 1, include library 1. If we're compiling up to library 2, then include library 2, etc. And it keeps on going. Now, this indentation is a little bit weird, where it doesn't immediately make sense. It immediately makes sense to me, and I indented it this way just because it's easier to see the dividers, where this is the second library, this is the third library, this is the fourth, and this is everything that relates to it, right? But my visual indentation really doesn't match how these if statements are working, right? Because this if, its end if is right here, right? And its else is right here. So if we're compiling up to this library, then we're going to include that library. Otherwise, we're not going to include the library. And when we don't include the library, we set the include tag to 0. And if we do include the library, we set the number equal to this library chain constant. And the reason we do that is for a little bit of extra redundancy, because we have data before functions. After we do this very redundant process, we do the exact same thing in the functions. So functions after data, the exact same pattern. So libchain2, and then we define the exact same define as before. Now the thing is that we use the same exact number. So if we don't use the same exact number, it gets a redefinition error, and then we know we made a mistake somewhere, because right now we have a kind of like a parallel arrays problem, where we have this structure right here is for the functions files, and it's right here, the functions, right? And then this structure up here is like exactly the same code almost, except it is for the data files. And so it's very similar to paired arrays, and people don't like paired arrays because I don't know. I kind of understand why it might not be as easy to manage paired arrays as it is to just have an array of objects. But you know, right, and it's also, this is more error prone, so I've added some contingencies to make sure that this is in the exact same order as this. But there's another thing benefit we have to here. We have redundancy, right? We have these two very almost identical structures, except that this is .f here. So in libchan number 3, we're including a .f underscore file, and if we go over to the third library over here, we're including a .d underscore file, but everything else is pretty much the same. And you might say, well, that's really a waste, right? And I don't think so. I don't think it's a waste, because redundancy is good. Redundancy and rigidity, I think, are actually good things to program. A lot of people don't see it that way. But I think a lot of people think code is a lot more flexible than it really is. And code, I think, is more like a house than it is some type of ethereal thing that can just be refactored to your heart's content and just molded and shifted around as much as you want. So I think code is not as much like wet clay as people think it is. It's more like a house, right? Where you want to do some refactoring and change some things around. Okay, we need a different garage. Okay, just knock down the entire garage, start over, right? Or not, bust out some walls and completely gut the room and then start over, right? Um, so refactoring, in my mind, is not as flexible as people think it is, and it's not as trivial either. Also, another big issue I have is people refactoring stuff just because it'll look better or it will read better, and it's some type of superficial refactor. An analogy to make would be, man, this car, it uses these red colored bolts, but I don't really like the red colored bolts. Can we, like, take out all the bolts in this car, and then we're just going to put in blue bolts, right? And right, we're not going to change the size of the bolts or anything. Physically, they're going to be the same strength and everything, same thread count, same thread spacing, everything exactly the same. I just want to change the color, so let's take out all these red bolts and put these blue bolts in. So theoretically, that is a refactor that should not change any functionality. Seems really straightforward. But you know what? Every time you refactor, you risk breaking something. I don't think there's such thing as a trivial refactor. Um, and right, so you take apart the car and try to put in these other bolts, and maybe something breaks when you're taking it apart. Maybe you miss a bolt when you're putting it back together. Um, Maybe there's a bolt hidden somewhere that you don't know it's there, and so you don't change it. And that actually happens a lot in JavaScript, where you have like a executable string, and so when you're trying to do a refactor, you refactor all these variable names, but there's this one variable that's actually stored in a string, and then it's looked up in a dictionary, and so you don't refactor that, and you miss it, and then you're screwed. Or even worse, I don't recommend doing this, but what if you're using reflection and the variable name is like uh, constructed in a string builder at runtime, and so you totally miss it. You can't control F for it. Your refactoring tools just can't find it. Um, and then you try to refactor it, and bam, it breaks on you. Now, one solution for that is, well, don't write code that can't be refactored with simple tools. That's one way, and I totally agree with that, because if look at my code over here. It's in Notepad++. I think that I'm using C and I'm using Notepad++, and it's very intentional. Like, I've used, when I was a kid, I used Visual Studio all the time, and I wrote Visual Basic programs, and I wrote a game in Flash Develop, and I used those autocomplete functions all the time. But that extra speed of development actually led to really crappy code, because you relied so much on the autocomplete that you didn't meticulously organize things in a way that would just make the code easier to understand from just looking at it. So my goal is to, you know what, let's not try to write the code so fast. Let's not worry that we're losing a few seconds trying to look up a function, right? If we try to look up a function, that's better, because it's gonna help us memorize what that function is, right? How do we make sure we can easily remember functions? Okay, let's make sure we have a very consistent naming scheme, so that we can always find a function we're looking for, because the code base is so consistent. And if we're very consistent with our names, we don't need any autocomplete, because the names are just that consistent. And if you have autocomplete, you start to lean on that crutch too much, and it could hinder you. Now, there could be something to be said for, well, maybe you should just write a project without using autocomplete, and then once you have the discipline to write good code, then you can go back to using autocomplete with your better skills, right? And that might be a good way to do it. But I don't know. I don't know if you can separate your mind from your environment. I think your mind and your environment are very tightly coupled, more tightly coupled than you realize. So, just the act of coding in Notepad++ is going to yield different code than coding in Eclipse or Visual Studio, right? Even after you have the discipline to code well-written code, even after you have all that discipline, once you move to a more fancy IDE, the style of your code is going to change. Even despite being aware of it, even despite efforts to keep on writing in the same style, it's going to change. There's a good analogy where there's this computer scientist who runs to work every day barefoot, and even though he does that every single day, the moment he puts shoes on and runs, his gait immediately changes. So even though he's aware of how he changes his gait when he runs, when he's doing it barefoot, right? Because you don't have as much padding when you don't have shoes, so you have to be more delicate on the bottoms of your feet, and so you're going to be a lot nicer on your joints when you run barefoot. Even though he's aware of all that and he's aware of the gait changes, it still is going to happen. He's still going to run differently when he puts on his shoes. Even if he tries to make an effort to run like he's barefoot while he's wearing shoes. And so same thing with this IDE, I think, where if you the IDE you're using is going to change how your code looks. For example, you notice that all my code is very lined up. Now, if you were an IDE that made it a complete pain in the ass to line stuff up, your code would just not look like this, because it would be so hard to write code like that you would just never do that. And I had a boss who really hated how I lined up code, and it makes sense because when he tries to go edit it, he can't fucking edit it because that's not the way he edits code, right? If you were doing all of this in Emacs, you would be like, fuck this shit, this is atrocious, right? But I have an art degree, so I think that there's something to be said for the visual style of your code and how it looks. People say that, how your code looks doesn't matter, but I think it does. Going into that, think about fast and slow thinking, right? There's a concept called fast and slow thinking, where some things are processed instantly, and other things need to employ some higher level cognition that takes more time. So when you align everything in your code, you can actually find bugs in your code by just looking for where a pattern is broken, right? You don't have to analyze it at a very deep level. You can use the fast thinking aspect of pattern analysis and just looking for visual anomalies in your code, right? So I see a 3, I see a 4, I see a 5, I see a 6, I see a 7, right? If I saw a 6 and a 6, 5, 6, 6, 8, I'd be like, okay, there's a bug in my code, right? So by doing that, I can analyze the patterns in the code, right? And I see 4s, I see a 4 here, I see a 3 here, I see a 5, I see a 6, I see a 7, I see an 8, right? So I can immediately scan over the code and pick out bugs, right? And some bugs like that, especially a transposition error where you flip a X and a Y, or you miss a X or a Y, those can be really hard to find bugs because they can give you really weird behavior. So lining things up is kind of important for that, right? So R, G, B, A, right? Keeping a consistent order where it's R, G, B, and A, and then keeping these numbers, right? We wouldn't want to order this A, G, B, R, right? Because then the numbers wouldn't have this sequential pattern here, right? So just lining everything up, right? So R, G, B, A, 0, 1, 2, 3, keeping it in that order. So that you can easily look at it and go 0, 1, 2, 3. Okay, that makes sense, right? So just having that visual aspect to the code so that you can easily just look at it really quick and identify if there is any obvious problem. Because in the end, if you think about the halting problem basically says, you cannot write a program that can analyze if it's correct. So that means that the proverbial buck stops with you. Yes, you can write some tests, and you can put asserts in your code, you can have debug code that checks the input parameters for functions, right? You can do all of that. But in the end, I believe it was Alan Turing kind of proved that you cannot write a program that can prove itself to be correct. So you can do all of that, and that's going to help you, but there's still going to be those few things that if you had only organized the code nicer, you would have found them, right? Because when I was a kid, I used to make so many mistakes where I would always flip X and Y accidentally, and it would create these bugs that were like really hard to find. Eventually, as you got used to seeing that weird behavior and knowing what kind of bug it came from, then it became a little bit easier to fix. But still, I'd rather not have weird, mysterious behavior. I would rather just write it right the first time, and then just have unit tests as like an insurance policy. But in the end, when everything else fails, you better have your code written nicely. So let's see. That looks good. So, anyways, so with those thoughts, I think that what I'm gonna do is I'm gonna take the all the functionality that I need. I'm just gonna put it in gpudata.d and gpudata.f, and that's how I'm gonna do it. Now I need some type of editor. So I guess I got to think about how I want the. I'll be back. I'm gonna stop recording and start again.